In this video, we're going to have a look at how F equals ma can be used in calculation. So there's a few things that you want to label before we even start this question. The step number one, you want to label the direction of the acceleration. So it tells you there's a particle A, which has a mass of 5 kg. There's a particle B, which has a mass of 4 kg. Now, if this is hanging freely, so it does tell you the distance that it's hanging above the ground. Let's see if that does help at some point in the question. But it makes sense that B is sort of pulling it downwards, because it tells you that particle A does not reach the pulley before B reaches the ground, meaning the direction of acceleration for B would be downwards. In that case, A would have to move to the right. What you then want to label is all the forces acting on the diagram, but you want to label all the forces that are either acting in the direction that it's moving or acting against the direction that it's moving. It's important that you make a note of that, because although you can label the weight of A as mg, that's acting perpendicular to the direction that it's moving in, so we don't include it in our F equals ma calculation. Again, we only include forces that are in the direction that it moves or opposing the direction that it moves. Sorry, that line was a bit bent. So let's establish those. There's always going to be tension acting on a rope, and tensions, they act on both directions, from A towards the pulley, from B towards the pulley, and they always approach each other. Like I mentioned, we're not going to take into account the weight of A because that acts perpendicular to the direction that it's moving in. However, the weight of B acts downwards, which is in the direction that it's moving in, so you can take into account. Weight is equal to m times g. In this case, it's the mass of 4 multiplied by acceleration due to gravity. In F equals ma, a lot of students make the mistake of breaking down what F is. F always stands for resultant force. So let's write that down first. A resultant force isn't just taking one of the forces, it's taking the force in the direction of motion, which in this case is 4g. So let's label this for particle B. It's 4g in the direction of motion, and you take away from it the forces that are opposing the motion. In this case, because it's going downwards, this upwards force is opposing the motion. So you take away tension, and that's equal to the mass of particle B, which is 4, multiplied by its acceleration, which we don't yet know, so I'm just going to label that as A. Forming the same equation for particle A, we can say that the force pushing it in its direction of motion, which is just tension, take away the forces opposing B. In this case, there are no forces acting to the left of B, so there's nothing opposing particle A. And that's equal to the mass of particle A, which is 5, multiplied by its acceleration. Now that we have these two equations, you want to think about how you can find the value of A and T. Because there's two unknowns, you deal with them as simultaneous equations, or you can put one into the other. In this case, it's easiest to replace T here with 5A. So you have 4g minus 5a equals 4a. But then you're probably thinking, okay, but that will allow me to solve for acceleration. We want the tension. But once you have the acceleration, you can put into any one of these two equations to then find the tension. In this case, you can add 5a to both sides, in which case we get 4g on the left-hand side is equal to 4a plus 5a, which is 9a. You can then divide both sides by 9 to get 4 over 9 multiplied by g is equal to acceleration. Once you've got acceleration, because it is the middle of the question, it's best not to round, so we're going to leave it in this exact form. But we can actually put it into the tension formula, and we get tension is 5 multiplied by this acceleration value, 4 over 9g. 5 times 4 is 20, so that becomes 20 over 9 multiplied by g. I'm just going to leave it in this format here, but you can put it into a calculator to get an actual numerical value of tension. And that's everything you have to do in this question. So step number 1 is always labeling the direction of acceleration. Step number 2 is labeling the forces that act sort of in the direction of acceleration or against the direction of acceleration. And step number 3 is forming F equals ma equations, and you can take it from there. It really depends on the question. Be sure to like the video if it helped and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.